Implement MST, multiple spanning tree topology. Two switches for distribution and one switch for access and PC. Use this image Cisco iOS VL2 for the set the host name D1, D2, A1. Connect the devices gigabit 101, 5612, 5634, and 23. Okay, my ports are different, so I will use similar ports. For example, gigabit 01 to gigabit 01. And instead of 5 and 6, I will use 11 and 12. So 11 to gigabit 01, 12 to gigabit 02, 11 to gigabit 03, and 12 to gigabit 10. The PC and port 23 to PC. Okay, I'm using these ports. Cisco per VLAN spanning tree PBST Plus provides a significant setup from a standard spanning tree in terms of flexibility. PBST Plus allows each VLAN to have its own independent spanning tree, thereby making better use of available links in the network. A drawback to PBST Plus is that there is an instance of PBST Plus running for each VLAN in the network, regardless of whether there are different spanning tree topologies required. This presents the potential for overwhelming the switch CPU and memory. Additionally, Cisco switches support finite numbers of PBST instances, and more VLANs are created than there are PBST Plus instances supported on a particular switch. Some of the VLANs will not have any STP running, and therefore not have any switching loop protection. PBST Plus and Rapid PBST Plus are simply unusable in that kind of environment. Lastly, PBST Plus and Rapid PBST Plus are Cisco proprietary protocols and generally unusable in mixed vendor environments. Cisco was involved in the early development of multiple spanning tree. MST was standardized as IEEE 802.1s in 2002 and merged into 802.1q in 2005. MST is an open protocol derived from RSTP, sharing all its rapid convergence properties. And in fact, the only standardized spanning tree protocol for VLAN-based networks supported by multiple vendors. MST is a compromise between common spanning tree and per VLAN spanning tree. An MST instance represents a unique spanning tree topology. Multiple MST instances can be created to account for each of the required spanning tree topologies in a network, and an arbitrary number of VLANs can be mapped to a single MST instance. You will set up two instances of MST, one for VLANs 2 and 3 and other for VLANs 4 and 5. All other VLANs will be mapped to the default MST instance. also referred to as IST or internal spanning tree. This lab is an exercise in deploying and verifying MST and does not reflect networking best practices. Required resources on real lab: 2 switches, 3650. In my case, I'm using Image iOS VL2. 1 switch, 2960. In my case, I'm using Image iOS VL2. 1 PC, I'm using a virtual PC from VirtualBox. Cables. Build a network and configure basic device settings. Configure basic settings. Okay, copy this on Notepad. The basic configurations for the 3 switches. Copy this to a Notepad. Okay, this is switch D1. Hostname, banner, spanning tree rapid, line console, interface range, shut down all range of interfaces, but my range is different. From 00 to 03, from 10 to 13, from 20 to 23, from 30 to 33. Okay, so change this. Okay, gigabit from 00 to 03, gigabit from 10 to 13, gigabit from 20 to 23, and gigabit from 30 to 33. Okay, from 0003, 1013, 2023, 3033. Shut down all interfaces and configure 3 interfaces as trunks. In my case, gigabit 01, 11, and 12. Gigabit 01, 11, and 12. Okay, these 3 interfaces, trunk and not shut down. Okay, 01, 11, and 12. Switch port mode trunk, not shut down, and create VLAN 2, VLAN 3, VLAN 4, VLAN 5. Okay, and remember on layer 3 switches, before to configure trunk, use switch port trunk native VLAN and encapsulation .1q. Okay, and start the switches. Start, then start. Okay, switch 2. Hostname, banner, line console, spanning tree. The range of interfaces is the same because it's the same switch. Shut down all interfaces, and the trunk interfaces are the same as D1, so it's the same range for the trunk interface, and also the encapsulation. Okay, paste here. Okay, the same range of interfaces for trunks, encapsulation, no trunk, no shutdown. VLAN 2, 3, 4, 5. And switch A1. Hostname, banner, spanning tree, line console. The range of interfaces shut down all interfaces. And the interface range On this switch, the interface range for trunks are 01, 02, 03, and 10. Gigabit 01, 02, 03, and gigabit 10. Okay, four ports. 01, 02, 03, and 10. 01, 02, 03, and 10. Okay, and remember the encapsulation. Okay, for interfaces, the encapsulation mode trunk enable the interface connected to the PC. Okay, this interface 2.3 is gigabit 2.3 and enable the interface VLAN 2, 3, 4, 5, and 6. Okay, go to D1, D2, A1. Okay, D1, copy this. D1, enable configure terminals. Once you are on global configuration mode, right click to paste. Sorry. Copy again and right click to paste. Okay, and review for issues and errors. No errors, all commands accepted. Very nice. D2, copy. D2, enable configure terminal. Right click to paste. Okay, very good. And switch A1, copy. Enable configure terminal. Right click to paste. Okay, and review. Very nice. Save the running configuration on real app. Outputs and spanning tree topologies highlighted in the slab may be different than what you observe using your own equipment. Implement and observe MST. Configure MST on D1 and D2. In this step, we will configure MST on D1 and D2 only. We will do this so we can observe their interaction with each other as well as their interaction with A1. On D1 and D2, issue command spanning tree mode MST. Okay, on D1 and D2. D1 spanning tree mode MST. Enter. D2 spanning tree mode MST. At this point, with no MST specific configuration, MST instance 0 is operational for all VLANs. Issue the command show spanning tree, and you will see in the output that the spanning tree information is about MST 0. Issue the command show spanning tree MST, and you will see MST specific STP information that is specific to MST 0 only. Take note of the information displayed for the interfaces. Gigabit, in my case, is 11 and 12. These interfaces 11 and 12. because they are connected to a switch that is not running MST. The switch A1 is not running MST. Their types is listed as P2P bound PBST. So that means the another side is using the another peer is using still is using per VLAN spanning tree. Okay, show a spanning tree on D1. Okay, and show spanning dash 3. Spanning dash 3. And now MST0. Okay, look at the gigabit 01 is root port and forwarding state, but and this is gigabit 01 root port forwarding state, but 11 and 12 designated ports on forwarding state, but bounded, okay, bound per VLAN spanning tree. Okay, 11 and 12 bound per VLAN spanning tree means okay, A1 is still using per VLAN spanning tree. And also show a spanning tree MST, and you can see the similar output gigabit 01 root port forwarding state gigabit 11 and 12 per VLAN spanning tree bound. And VLANs mapped to MST0 are from 1 to 4 times 4094. Okay, all VLANs mapped to MST0. The basic behavior of MST is the same as spanning tree, where a root bridge must be selected, the root ports, and finally best paths to the root bridge from all known root bridges. Okay, and D1 show a spanning tree. You can see the base MAC address of the root bridge is 0D51F59F00, and my local ID is the base MAC address of my local switch is a different MAC address. So D1 is not the root bridge. Okay, also you can see on show spanning tree MST, my local bridge, the base MAC address is different of the root bridge. So D1 is not the root bridge. But go to D2 and show spanning tree MST. In this case, the root D switch is the root for CIST, okay, for the internal spanning tree. That means D2 is the root bridge. Okay, in the current network, we can see that D2 has been elected the root bridge. The bridge priority defaults to 32,768. So the election is based on D2 having a lower base MAC address. Okay, D2 has a lower base MAC address. 00D51F59AF00, and D1 00D51FC5300. Okay, so this number is higher than the number of the base MAC address of D2. Okay, and the priority of D2 is this 32,768. The switch elected as root may be different in your lab topology, but the rules for election remain the same. Show spanning tree root on switch A. On switch A and show spanning tree root. Now you have 5 VLANs and 5 root ports, all ports on gigabit 03. Okay, gigabit 03 is the root port for all VLANs because D2 is the root bridge for all VLANs and gigabit 03 is the root port. Okay, the best path to reach the root bridge. Show spanning tree root on D2 and the output will be different. Show spanning tree root. For MST0, no root ports because D2 is the root bridge. No root ports here, no root ports because D2 is the root bridge. And D1, show spanning tree root. The root port is gigabit 01. Okay, the root port is gigabit 01. The best path to reach the root bridge that is D2. Okay, the root bridge for all VLANs is D2. And the root ports if D2 is the root bridge for all VLANs, gigabit 03 is the root port for 5 VLANs, and gigabit 01 is the root port for MST0. Okay, A1 is the root port for 5 VLANs. On A1, gigabit 03 is the root port for 5 VLANs, and on D1, D1 has gigabit 01, the root port for MST0. This is because with MST, only one instance of the spanning tree algorithm runs, regardless of the number of VLANs mapped to it. On A1, use MST, spanning tree mode MST. And finally, on A1, configure terminal spanning tree mode MST. And you can verify again and show spanning tree root. And now, before to apply MST, the instance is showing 5 VLANs, and after apply MST, only one instance MST0, and MST0 manages all VLANs. And the root port is still gigabit 03. The root port is still gigabit 03. And go to D1, for example, and do the following: show spanning tree MST, show spanning tree MST, and the gigabit 11 are not anymore bound PBST. Okay, before was BBST because A1 was running per VLAN spanning tree, but now the A1 is running MST. Configure, turn, and verify basic MST operation. Create and verify MST configuration. MST allows network engineers to reduce the load of spanning tree protocol while still providing unique spanning tree topologies for groups of VLANs. MST configuration must be completed by hand on each switch individually. Complete the following task on switch D1. Enter MST configuration mode using the command spanning tree MST configuration. Okay. For example, go to D1. Or in my case, start for the root bridge, start from D2. Okay, I will start from D2, the root bridge, and configure terminal spanning tree mode, spanning tree MST configuration. Enter. Now you are on MST configuration mode. Configure MST region. Okay, the region, choose a name, CCNP version A. Enter. The revision number, revision 1, revision 1. Oh, sorry, revision 1. Configure instance 1 to include VLAN 1 and instance 2 to include VLAN 4. Okay. Instance 1 include in this instance VLAN 2 and instance number 2 to include VLAN 4. Okay, and commit configuration by typing exit. Okay, and show spanning tree MST to verify, and show spanning tree MST. Enter space. Now you have three instances: MST0 and VLANs mapped 135 to 1, 3, and from 5 to 4000 and MST1 is VLAN number 2 assigned to MST1 and VLAN 4 assigned to MST2. Okay, that is very good. While spanning tree MST configuration mode, you can use show current and show pending to view current and pending configuration settings. This configuration does not propagate to other switches. Each switch exchanges digest information summarizing the VLAN to instance mappings it has configured. If a switch receives a BPDU with a different digest, it assumes that the sender is in a different MST region. The output below is what A1 shows in the topology used to create this lab. Notice that the ports connected to D1 are classified as peer-to-peer bound RSTP. Okay, on A1 show spanning tree MST. Okay, show spanning tree MST. And now you can see only one instance, MST0, all VLANs mapped to MST0, and gigabit 03 and 10 bound RSTP. Gigabit 03 and 10 bound RSTP. Okay, because D2 now is configured with three instances: instance 0, instance 1, and instance 2. So that's why A1 shows gigabit 03 and 10, the ports connected to D2 bound RSTP with only one instance. Show spanning tree MST configuration digest on A1. Show spanning tree MST configuration digest. Okay, and now you can see the revision is 0, instances configured only 1. This is the digest. And show the digest from D2, the configured switch. Okay, I will use D2 because I configured the instances on D2. Show spanning tree MST configuration digest. Okay, revision 1, instances configured 3, the digest. As you can see here, the digest values are different. Configure MST on D2, change the revision number to 2, and add VLAN 3 to instance 1 and VLAN 5 to instance 2. Okay, the lab is configuring all on D1. I'm configuring all on my root bridge D2. So proceed on D2 in my case. On D2, configure terminal spanning tree MST configuration. You can use show current to view the current configuration. Instance 0 with the remaining VLANs, 1 with VLAN 2 and 2, instance number 2 with VLAN 4. So change the revision to number 2, and on instance 1 assign VLAN 3 and instance 2 assign VLAN 5, and show pending. After save the changes, 0 will have the remaining VLANs with 1 will have 2 and 3 and 2, 4 and 5. So exit to save and end and verify. Okay, and verify show spanning tree MST. Okay, instance 0, all remaining VLANs, MST, instance 1, 2 and 3, MST, instance 2, 4 and 5. Very nice. Now configure D1 and A1 with the same configuration. Okay, name of the region, CCNP B8, revision 2, instance 1, VLAN 2 and 3, and instance 2, VLANs 4 and 5. After completing the configuration on the switches, the output show spanning tree MST on A1 should be similar to the output on and D2 in this case is the root for all 3 instances. Okay, go to D1 configure terminal spanning -3 MST configuration. The name CCNP version 8. The revision is number 2. Instance 1, VLAN 2 and 3. Instance 2, VLAN 4 and 5. And review show pending. And this will be the configuration, the name, the revision, 3 instances, 1, 2, 3, and 2, 4, 5. Exit. And the same process on A1. configure terminal spanning tree MST configuration and name CCNP V8 revision 2 instance 1 belong 2 and 3 instance 2 belong 4 and 5. Show pending to verify pending. Very good. Exit. And on A1, for example, review and show spanning tree MST space MST 0, MST 1, 2 and 3, MST 2, 4, 4 and 5. And for example, for MST 1, the root port is gigabit 03. Okay, very nice. MST 2, the root port gigabit 03. Okay, root port gigabit 03 for all instances. And the root port also here, the root port. Controlling the root bridge. Just like with per-VLAN spanning tree plus and rapid per-VLAN spanning tree plus, the current root bridge was selected based on the lowest bridge ID, consisting of the priority extended system ID equal to the VLAN ID and base MAC address values. Okay, the priority, the extended system ID is 1 and base MAC address. With the priority and standard system IDs being identical, the root bridge MAC is numerically smaller than the local bridge MAC. The result is that in a completely unconfigured network, one single switch will be elected as the root bridge. The resulting choice of switch may or may not be desirable. Okay, so D2 has the lower base MAC address than A1 and D1. D2 has the lower base MAC address. Okay, in all cases. And with PBST plus or Rabbit PBST plus, root bridge selection is done for each VLAN. With MST, the root bridge is based on instances. There are two basic ways to manipulate the configuration to control the location of the root bridge. The spanning tree MST instance ID priority value command can be used to manually set a priority value. The spanning tree MST instance ID root primary or secondary command can be used to automatically set a priority value. The difference between the two is the priority command will set a specific number multiple of 4096 as the priority, while the root primary command will set the local bridge priority to 24,576 if the local bridge MAC is lower than the current root bridge MAC, or 4096 lower than the current root's priority if the local bridge MAC is higher than the current root bridge MAC. The logic behind this operation is straightforward. The root primary command tries to lower the priority only as much as is needed to win the root election, while leaving priorities between 24,576 and the default 32,768 for use by secondary bridges. The command always takes the entire bridge ID into account when computing the resulting priority value. The spanning tree MST instance secondary command will statically set the local bridge priority to 28,672 in an otherwise unconfigured network where all switch priorities default to 32,768. The root primary command will set the priority on the switch to 24,576, two increments lower than the default priority, while the root secondary command will set the priority on secondary root to the 28,672, one increment lower than the default priority. Modify D1 and D2 so that D1 is selected the primary root bridge for MST instance 1 and D2 is selected the primary root bridge for MST instance 2. D1 should be elected as the secondary root bridge for MST instance 2 and D2 should be elected as the secondary root bridge for MST instance 1. You will need to make configuration changes on both D1 and D2. The commands used at D1, the following example. Okay, go to D1, spanning tree MST. For instance 1 will be the root primary, and for instance 2 will be the root secondary. Okay, and go to D2, configure terminal, and spanning tree MST for instance 1 will be the root secondary, and for instance 2 will be the root primary. Very nice. After you have configured both D1 and D2, go to A1 and issue command show spanning tree root. Okay, in this output you will see root bridges differentiated. Go to A1 and show spanning tree root. Enter. Okay, for MST0, gigabit 03, the root port, but for MST1, gigabit 01, and for MST2, gigabit 30. Why? Now, the root bridge for instance 1 is D1, and the root bridge for instance 2 is D2. So the best path, the route to reach the root bridge on instance 1, the route for instance 1 will be gigabit 01, and the route for instance number 2 will be 03. Okay, so this is the direct link to reach the root bridge on instance 1, and this is the direct link to reach the root bridge on instance number 2. Okay, so on A1, for instance 1, gigabit 01, for instance 2, gigabit 03. Okay, very good. You can see that the root port for VLAN 1 or instance 1 is, in my case, gigabit 01, and the root port for instance 2 is the gigabit 03. And also you can verify show spanning tree MST space, and on A1 you can see MST1. For MST1, A1 has the root port, so so A1 is not the root bridge for MST1. on MST2, A1 has the root port, so A1 is not the root bridge for MST2. And also for MST0, A1 has the root bridge for MST0. A1 has the root port for MST0, so A1 is not the root bridge for MST0. And simply go to D1, show, enter, and show a spanning tree MST. Okay, for MST0, you have a root port. So D1 is not the root bridge for MST0. For MST1, this switch is the root. D1 is the root for MST1, no root port. And for MST2, D1 has the root port, so it's not the root bridge for MST2. And go to D2 and show a spanning tree MST. And MST0, no root port, and this switch is the root for internal spanning tree. Okay, so D2 is the root bridge also for MST0. Okay, and for MST1, the root port, so D2 is not the root bridge for MST1, and for MST2, this switch is the root, no root ports. Very good. Adjust port cost values to impact root and designated port selection. As the network is implemented right now, there are two direct paths between switch A1 and the root bridge for each MST. Path and port costs are evaluated to determine the shortest path to the root bridge. In the case where there are multiple equal cost paths to the root bridge, additional attributes must be evaluated. In our case, our interface number, for example, gigabit 01 is chosen as the root port, and the higher interface number, for example, gigabit 02 is put into a spanning tree blocking state. Okay, for example, on A1, gigabit 01 is preferred than gigabit 02 because the number of interface is lower. And gigabit 03 is preferred over gigabit 10 because the number interface is lower. Go to A1, and now you can see for MST1, gigabit 01 is the root because it's preferred. The priority is equal for gigabit 01 and gigabit 02. The priority is equal 128, but the number is lower for gigabit 01 and is preferred to be the root. And the same way on MST2, gigabit 03 is preferred for root because the number is 4, and from gigabit 10 the number is 5. Okay, on this side. You can see which ports are blocked with show spanning tree VLAN ID or the show spanning tree blocked ports. Okay, on A1, show spanning tree VLAN 1 or MST1. On A1, show spanning tree MST1, only MST1. And you can see gigabit 01, and you can see gigabit 01 is preferred. and show spanning tree blocked ports. Okay, for instance 1, the blocked ports are 2, 3, and 1, 0. Okay, and alternate role 0, 2, 0, 3, and 1, 0. Okay, while gigabit 01 is the root port in some forwarding state. As you can see, MST1 has its root port on gigabit 01. Okay, gigabit 01 is the root port, and gigabit 02, 03, and gigabit 10 are alternate blocking ports. Gigabit 02, 03, and 10 alternate blocking ports. Okay, blocking ports. To manipulate which port becomes the root port on non-root bridges, change the port cost, a value between 1 and 200 million, or port priority value, a value between 0 and 240 in increments of 16. Remember that this change could have an impact on downstream switches as well. Do not make these changes in a production network without careful planning and prior coordination. On A1, shutdown interfaces gigabit 01 and 02. Assign a new port cost of 1000 to gigabit 02 using the spanning tree MST1 cost value command, and then issue no shutdown. Okay, on interfaces gigabit 01 and 02 and A1, shutdown. Okay, shut down these two interfaces, gigabit 01 and 02. On gigabit 02, the cost for MST1, the cost 1000. Okay, for gigabit 02, the cost 1000. And gigabit 01 and 02 enabled with no shutdown. Okay, go to A1 and verify the cost. Look at the cost, 20,000 for gigabit interfaces. Okay, 20,000. For a fast Ethernet interface in the lab, the cost by default on MST is 200,000. But for gigabit, in my case, for gigabit interface, the cost by default is 20,000. Okay, in my case is 20,000. The cost is 20,000. Okay, on both sides. And configure terminal, interface range, gigabit 01 and 02, shutdown, exit, and only select gigabit 02. Okay, only gigabit 02 and spanning tree MST1 for instance 1 cost 1000. Spanning tree MST for instance 1, the cost, I will use 100. Okay, I will use 100. Enter, exit, set the range gigabit 01 and 02, no shutdown, no shutdown, exit. Okay, and verify. Show spanning tree MST1. Now the root port is gigabit 02 with a cost of 100. Okay, I changed the cost for gigabit 02. I changed the cost to 100. And now 100 is lower than 20,000, so gigabit 02 now is the root port for instance 1, for MST1. Okay, gigabit 02 the root port. Now gigabit 01 is alternate blocking state. Okay, verify, show spanning tree MST1, show spanning tree blocked ports. Okay, also show blocked ports. On MST1, the blocked port is gigabit 01. Okay, the alternating blocking state, gigabit 01. From the output, you can see that the root port selected by A1 for MST1 is now interface gigabit 02, and the port and root cost is now 100. Okay, 100. Adjust port priority values to impact root port selection. The next method to impact root port selection is configured on the root bridge itself. In our current network topology, A1 has two connections to the root bridge for MST instance number 2, switch D2. The root port has been selected, in this case based on the lowest port ID. Port ID is made up of two values, labeled as priority and MBR, the number. The port number is not necessarily equal to the interface ID. A switch may use any port number for STP purposes as long as they are unique for each port on the switch. The port priority can be any value between 0 and 240 in increments of 16. Older switches may allow settings the priority in different increments. On A1 issue, show spanning tree MST2. Okay, on A1, show spanning tree MST2. And the root port is gigabit 03. The cost is 20,000. Priority 128. Number 4. And was preferred than gigabit 10. The cost is equal, the priority is equal, but the number is higher than gigabit 03, so gigabit 03 is preferred. Okay, gigabit 03 was preferred than gigabit 10. And modify the port priority of D2 interface gigabit 12. Okay, change the priority on 12 so that it becomes the preferred port by issuing the spanning tree MST2 port priority value interface configuration command. Use value 64. Okay, and shut down interfaces 11 and 12. Then select interface 12 and change the priority to 64. Select 12 and change the priority to 64. And the interface range of 11 and 12 and enable bot not shut down. Okay, go to D2 and show spanning tree MST2. Show spanning tree MST2 instance 2. All ports are designated ports because they are because this is the root bridge and the priority on all ports are equal, and change the priority for gigabit 12 to 64. Configure terminal interface range. Select gigabit 11 and 12. Shut down bot. Exit and interface range. So select interface gigabit 12 and spanning tree. Spanning tree MST2 port priority. MST instance 2 port dash priority 64. I'm sorry, 64. Okay, in increments of 32 in this case. Enter. Okay, exit and select both interfaces, interface range 11 and 12. No shutdown. Exit. Very good. And review again and show spanning tree MST2. And now the priority is 64. The cost is equal, but priority 64. Okay, repeat, show spanning tree MST2. Okay, dispute. Okay, and go to A1 and repeat show spanning tree MST2. And now the root port is gigabit 10. Okay, before the root port was gigabit 03, but now after configuration the root port is gigabit 10. Very good. Okay, on A1 issue show spanning tree MST2, you will see that gigabit 10 is now the selected root port. This selection is based on the lower priority value of D2 interface gigabit 12. Notice that the lower priority value does not appear in any A1 output. Okay, in A1, no. Okay, on A1. Thank you very much.